In this lesson we will be discussing two resistors in series with a third resistor in parallel. This circuit diagram shows two resistors in series in the first branch and one resistor, the third, in parallel. The branch containing the two resistors R1 and R2 in series is parallel to the branch containing R3. The total resistance in the first branch equals R1 plus R2. The total resistance in the second branch is equal to R3. Total equivalent resistance, since the two branches are parallel, is equal to the quantity R1 plus R2 times R3 divided by R1 plus R2 plus R3. The total current I in the circuit is equal to E divided by the total resistance, or I is equal to E divided by the quantity R1 plus R2 times R3 divided by R1 plus R2 plus R3, or I is equal to E times the quantity R1 plus R2 plus R3 divided by R3 times the quantity R1 plus R2. Again, since E equals I2 times R3, we get I2 equal to E divided by R3. And since I1 plus I2 equals I1 equals I1 minus I2. The voltage across R1 and R2 may be found as follows. Since V1 equals I1 times R1 and V2 equals I1 times R2, and I1 is equal to E divided by R1 plus R2, substituting I equals E divided by R1 plus R2 into the first equation gives V1 equal to E times R1 divided by R1 plus R2, and V2 equals E times R2 divided by R1 plus R2. The total power derived from the source is equal to P, which is equal to P1 plus P2 plus P3, or E times I. Using the circuit diagram shown, find the values of the total resistance, I1, I2, V1, V2, P3, and P. Total equivalent resistance can be found using the following equation. Total resistance is equal to the quantity R1 plus R2 times R3 divided by R1 plus R2 plus R3, or 5 ohms plus 4 ohms times 3 divided by 5 ohms plus 4 ohms plus 3 ohms, or 27 divided by 12 equals 2.25 ohms. The total current, I, is equal to E divided by the total resistance, which is equal to 18 divided by 2.25, or 8 amps. And I2 is equal to E divided by R3, which is equal to 18 divided by 3, or 6 amps. Therefore, I1 equals I minus I2, or 8 minus 6, which equals 2 amps. Checking, R1 plus R2 equals 5 ohms plus 4 ohms, or 9 ohms, and I1 is equal to E divided by R1, or I1 is equal to 18 divided by 9, which equals 2 amps. To find V1, use V1 equal to I1 times R1, or 2 times 5, which equals 10 volts. Then V2 is equal to I1 times R2, which is equal to 2 times 4, or 8 volts. And V3 equals I2 times R3, or 6 times 3, which equals 18 volts. To find P3, use P3 equals I2 times V3, or 6 times 18 equals 108 watts. Then P1 equals I1 times V1, which is equal to 2 times 10, or 20 watts. And P2 equals I1 times V2, or 2 times 8 equals 16 watts. The total power then is equal to P1 plus P2 plus P3, or 20 plus 16 plus 108 equals 144 watts. Checking, we use P equals E times I, or P equals 18 times 8, or 144 watts.